Hi guys, it's Mrs. Seitz. Today what we're going to be working on is we are going to keep on working on what we've been doing with word problems and pretty much just be reviewing them, but kind of putting everything together with slope-intercept form and point-slope form and just making sure that you can be able to read a word problem and pick out the important details. So today's focus is we're going to be solving real-life problems. So by the end of today's lesson, you're going to be able to figure out how you can use a linear equation in two variables to model and solve a real-life problem. So a linear model is a linear equation that represents a real-world scenario. And you can write the linear equation for a linear model in the same way you would write the slope-intercept equation of a line. So the y-intercept, which is part of slope-intercept form of a linear model, does not depend upon x. So let's write that down. The slope of the quantity that changes at a constant rate as x changes. So the change must be at a constant rate in order for the equation to be a linear model, okay? So some words and word problems that you might see or that you might have seen in the past and will continue to see for a slope, because remember, slope is change in y over change in x, and it has to be consistent throughout the entire word problem, consistent between the whole entire line. But the words that we need to look for to help identify a slope, because it's a unit rate, would be words like per and each. Sometimes we might be looking for a y-intercept in a problem, so we'd be looking still for those keywords like starts with and initial fee. So let's start out with having an equation given to us just as review, and then we're going to build up and start getting into some problems where we might not necessarily have that information with us. So we have to graph the equation y equals negative 0.2x plus 1. So if I'm thinking about what's the easiest way to graph this, we know how to do this in slope-intercept form. We know how to do this with standard form, with a table. I like slope-intercept form because it's already set up that way. I'm actually going to change this slope of negative 0.2 into a fraction so that I can graph that a little bit easier. So I'm going to change that into the fraction of negative 1/5. And I know my y-intercept is 1. So I'm going to start out at 1. And then remember what a slope of negative 1/5 means. It means go down 1 and then to the right 5. So down 1 and right 1, 2, 3, 4, 5. And make your next point. And you can do that a bunch of times if you want. But 3 points would be fine. And then you're going to draw a line that extends through those 3 points. Okay. Now, if we're trying to figure out what this actually stands for, okay, we have to know what this graph means. So it says the y-axis is our percentage in decimal form of the battery power. So it's good habit for us to label what the x and y-axis stands for. So the x-axis is hours, and the y-axis is percent of battery power. Okay, now when I take a look at my graph, okay, I can see that I have a point here on the y-axis at 1, so that has to be my y-intercept. So I'm going to write that down. 0, 1 would have to be my y-intercept. Okay, now the place where my graph is crossing the x-axis, remember to get that value, and you can kind of look and see where that's happening, but just to confirm, where you get your x-axis, that's where the y value is equal to 0, and you're solving for x. So just to make sure that I'm doing this correctly, I'm going to subtract both sides by 1. and then divide both sides by negative 0.2. And then I'm going to have an answer for my x-intercept. So it would appear that the x-intercept is at 5, 0. So if I'm interpreting what this actually means, for the x-intercept since x represents hours, 5 hours, 0, well, the y-axis is percentage of battery, so 0% battery. For the y-intercept, I'm going to do that here. So 0 hours and a 1, and this is in terms of percentage, I'm going to say 100% battery. Now for part C, it says how many hours is the battery power at 75%? Well, if I take a look at my y-axis, because that's going to tell me what my answer is, maybe it's not 100% clear on my line where that's going to be. So I'm going to use my equation to help me to get that answer. So again, the equation was y equals negative 0.2x plus 1. And I know the y-axis stands for percentage. So I'm going to plug in the 0.75 because this is a percentage. And since this is already in decimal form, I'm going to do 0.75 equals negative 0.2x plus 1, and then I'm going to solve that. So I'm going to subtract both sides by 1. I'm going to get negative 0.25 equals negative 0.2x. Divide both sides by negative 0.2, and I'm going to get my answer for x, which is going to be x equals 1.25. Now the unit in the problem, since I labeled my axes, it's going to be x equals 1.25 hours. All right, let's try another one. Okay, so this one, they're given the graph again. So it says to find the slope and the y-intercept. So the y-intercept is sticking out real nice and neat for us right here. It's where that line crosses the y-axis. It's where the x value is 0. So I know my y-intercept is equal to 32. All right, to get your slope, remember, you can do slope formula. I'd be really careful counting my rise over my run, because if you take a look, the y-axis is actually going up by 15s and the x-axis is going up by 10s. So we would do 86 minus 32 all over 30 minus 0. So when you calculate that correctly, you can punch that in your calculator. You got 86 minus 32 over 30 minus 0. You're going to get a slope of 9/5. So the equation you're looking for is y equals 9/5 x plus 32. And that's actually our answer for part B. So y equals 9/5 x plus 32. For part C, it says, what's the mean temperature of the Earth in degrees Fahrenheit? Well, if I label my axes, which it's already labeled for us, the y is in terms of degrees Fahrenheit and the x is in terms of degrees Celsius. So I know in my problem the equation is y equals 9/5 x plus 32. I know the x's in my problem are in terms of degrees Celsius, and I know the y's in my problem are in terms of degrees Fahrenheit. So if I'm looking at my picture over here, this mean temperature is in terms of degrees Celsius, so that means I'm going to be plugging the value of 15 degrees in for x. So I'm going to go ahead and do that and plug it in for the x value into my equation and calculate that to figure out what the value for 15 degrees Celsius would be in terms of Fahrenheit. So I'm going to use my calculator to do that. So I got 9/5 times 15 plus 32, and I'm coming up with an answer of y equals 59. So my answer is going to be 59 degrees Fahrenheit. And let's see if that kind of makes sense with our graph. So if I have something that's in between 10 and 20, follow that up on the graph. That looks like it's giving me an answer. It's pretty close to 60. So yep, that looks like that makes sense. So 59 degrees Fahrenheit is the correct answer for part C. All right, now if you notice, we're missing some things on example 3. We are missing a graph. So we're going to have to come up with a lot of information on our own right now. So guys, if we look at problem number 3, it says Diane knows a phone call to a friend costs 25 cents for the first 3 minutes and 10 cents for each additional minute. The number of minutes you call and the cost of a call are related. It says write a linear equation to model this problem. All right, so let's think about what's actually given to us in this problem. So I can see here the word each popping up. So it's 10 cents for each additional minute. So since I saw that word each, I'm kind of feeling like this is my slope in the problem. Okay, so I have a slope that's given to me, so that's a good thing. I'm going to write that m is equal to 0.10. Since I know slope is change in y over change in x, I'm going to write it like this for a sec. So it's 10 cents. Actually, let me write it like this so it's more mathematically correct. Let me get rid of that decimal point. So 10 cents per or each minute. This actually is revealing what the y is in the problem and the x. So the y in the problem is cents and the x's in the problem are minutes. So I'm going to set it up that way. So remember, x's come first, then y's. So that means the minutes will be first and the cents will be second. Okay, so we know have a slope here. So now that might actually help me out. I know it's 25 cents for the first 3 minutes. So to get that, that looks like it's a point. So that means I have 3 minutes and it's going to cost me 25 cents. Since I stuck with a decimal for my slope, I have to stick with a decimal over here for whenever I'm writing the money portion of it as well. All right, so I have a point and I have a slope. So I could technically go with slope-intercept form, but you know what? I'm going to start out right now with point-slope form. So I'm going to do y minus y sub 1 equals m times the quantity of x minus x sub 1. And I'm going to solve this thing for y so that we all come up with the same exact answer. Okay, so I'm going to distribute my 0.10. So I'm going to have y minus 0.25 over here. On this side, I'm going to get 0.10x, and then minus, let's see, 0.10 times negative 3. That's going to give me negative 0.30. All right, so then my next move is I'm going to be adding 0.25 to both sides. So then to get my final equation, it's going to be y equals 0.10x minus 0.05. So that would be my equation to answer part A. So again, just to kind of look back to make sure you understood that, I found that keyword of each, so that means that that was my slope. Remember, slope is change in y over change in x, so since I labeled that as 10 cents per minute or 10 cents each minute, I was able to identify that the cents was the y's and the x's were the minutes. All right, now that I have that under control, I'm going to actually use that to help me to figure out the cost of a 30-minute call. Since minutes I've identified as our x, I'm going to plug in 30 in for our equation, in for x. So I'm going to write down y equals 0.10, except this time, instead of an x, I'm going to put in a 30. Minus 0.05. And when I plug that into my calculator, I'm going to get $2.50. So the cost of a 30-minute phone call, according to this plan, is $2.95. All right, last word problem for us to try out together. So this one here says, at age 12, Patrick weighed 43 kilograms. At age 14, he weighed 50 kilograms. Patrick's age and weight are related. Write a linear equation relating Patrick's weight to his age. Okay, so it's not really specifying what we have going on in terms of x's and y's, so we have to define them ourselves. So I'm going to go with the straight order of the problem, going with age and then weight. So I'm going to start with age and then go to weight. So if I go like that, I don't see any slope in the problem because I don't see each or per popping up. I don't really see a y-intercept because I don't see a starts with. So I've got 2 points. I've got 12 matching up, so 12 years old, 43 kilograms. And then I see 14 years old matching up with 50. So to get this into equation, we need a slope, we need a y-intercept. So let's go with the slope first. So 50 minus 43 over 14 minus 12. Okay, so to get that answer, looks like I'm getting 7 over 2. I'm going to go with point slope form first. So I'm going to do y minus 43 equals 7 over 2 times x minus 12. I'm going to distribute to start solving for y. So I have 7 over 2x minus 42, I believe. Yep. And then I'm going to add both sides by 43. And the equation I'm coming up with is y equals 7 over 2x plus 1. Okay, so now I'm going to use my equation to find out Patrick's age whenever he weighed 38 kilograms. So the weight is the y value. So I'm going to write down my equation. So y equals 7 over 2x plus 1. I'm going to plug in a 38 in for y. It's really important to define what your x's and y's are so you know what you're solving for. Okay, so I'm going to subtract 1. Write it up here. I'm getting 37 equals 7 over 2x. I'm going to divide both sides by 7 over 2. And then I'm going to come up with my answer, which is, it's a weird number. So I'm getting an answer like 74 over 7. I think that's what my calculator is giving me. So 37 divided by 7 over 2. Yeah, it's giving me a weird answer. Who talks like that? 74 over 7. All right, so when you get a weird answer like that, that doesn't make sense. If I even make it into a decimal, it's about 10.6 if I round it to the nearest tenth. So if we're talking about in terms of age, okay, to round it to maybe even the nearest half age, we would say Patrick is about 10 and a half. So the most important thing, guys, with this lesson is just making sure you identify what the x's and y's are in your problem. So really making sure you define those. Also making sure you go through and look to see if you have a slope given to you in the problem. If you have the keywords like each and per, remember slope is a change in y over a change in x, so that should actually help you out with identifying an x and y too in the problem. Good luck with today's lesson.